practice a question involving a square root function in the denominator. So for example, f of x equals to x plus 3 divided by square root of x. So in such cases, whenever you have a rational function or even a function containing the square root function in the numerator or denominator, always find the domain. And here in our case, you know that whenever we have any function f of x in the numerator and the square root g of x in the denominator, so its domain you will write or focus in the denominator on the function which is written inside the square root function and maybe make it equal greater than 0. So keeping in mind this method, we will write the domain that x greater than 0, which means all real numbers which are greater than 0 and 0 is not included. Now once we are done with this one, the first thing is that we are going to take the derivative of this function. Of course, it's very obvious that here we are going to apply the quotient rule, and whenever we have some complicated functions, always try to break it into the parts and try to solve it so quickly and easily. So our first f function is x plus 3 and f prime, the derivative of this x is 1, so write it 1, derivative of 3 is 0, no need to write. And the g function is square root of x, which is a direct formula that derivative of square root x is 1 over 2 square root. Now for the quotient rule, we know that f over g whole prime equals to gf prime minus fg prime over g square. Now write the data from the left to the function. So here g, in our g, this is square root x, f prime which is 1, minus f which is x plus 3, don't forget to write it in the bracket, and g prime will be 1 over 2 square root of over g square, so square root of x with the square. Now make the denominators here alike. So we have 2 square root x, so multiply and divide the first term by the 2 square root x. Now we know that square root x times square root x gives us x. Similarly, square root of x square will give us also x. So we write the denominator one time, that is 2 square root x, and whole upon this square root x and this cancel, so you will have only x. Now square root x times square root x, we will get only x, and this 2 we will write it over here, minus, now open the bracket also with the minus sign. So minus x and minus times 3, minus 1 times 3, you will get negative of 3. And now we know a over b whole upon c, which is equals to a over bc. Now 2x minus x gives us only x minus 3 as an a, and bc write it properly as it is. So 2 square root x and times x. Now look here. Square root x means x has a power half and it is multiplying with the x. So when the two bases are alike, we just add the power. So half plus 1 will give us 3 by 2. So we will get x minus 3 over 2 x to the power 3 over 2. Why we are doing this? Because by doing this, our phenomena of taking the second derivative will become easy. So x minus 3 over 2 x to the power 3 over 2 is our first derivative. So copy down on the second slide and continue for solving second derivative. So x minus 3 over 2 x to the power 3 by 2 is my first derivative. Now take the second derivative. How will we find the second derivative? Again, apply the quotient rule, which says gf prime minus fg prime over g square. So our double prime x equals to f is our x minus 3 and the derivative of x minus 3 is only 1 and g is 2x to the power 3 over 2 and g prime, bring this over here. So you will get here 3x to the power 3 by 2 minus 1 will gives you again half. So 3x to the power half is my g prime. So put it here, g square, which will gives us 2x to the power 3 over 2 whole square. Now carry on g. So our g is 2x to the power 3 by 2 f prime. So it is my 1 minus f, that is x minus 3. Don't forget to write it in the bracket. And g prime is my 3x to the power half. Now what I will do, this square in the denominator is on the 2. So 2 square gives me 4. And this square is also on the this also as a power of x to the power 3 over 2. So look here, 3 over 2, power to the power, so they powers multiply. So this 2 and this 2 cancel. So we will have 4x cube only. Now multiply. 2 times 1 gives us 2x to the power 3 over 2. Open the bracket. So you are not only open the bracket with the negative sign, but also with the 3x to the power half. So let's try to solve it one by one. Better, don't open the negative sign. Don't open the negative sign. Only multiply 3x to the power half with the bracket which is inside. Which is inside the bracket. So let's multiply 3x to the power half times x. Now look on the at the right hand side. 3x to the power half times x. What do? We add the power if the bases are alike. So we will get 3x to the power 3 over 2. Now second, when we multiply 3x half with the 3, we will get minus 9x to the power half. Now open the bracket with the negative sign. So you will get 2x to the power 3 over 2 minus 3x to the power 3 over 2 plus 9x to the power half whole upon 4x. Now look at this. Here the power is 3 over 2 and here the power is also 3 over 2. So you can just add or subtract the coefficients. So 2 minus 3 you will get minus 1 x to the power 3 over 2. Then plus 9x to the power 1 over 2 all upon here we have 4x. Now you can solve it also by taking x to the power half common and then subtracting this with the power which is in the denominator, but no need to make your question complicated. Just make the equation the second derivative equals to 0 and then solve for x. So here minus x to the power 3 by 2 plus 9x to the power half over 4x cubed. So minus x to the power 3 by 2 plus 9x to the power half divided by 4x cubed. This is my second derivative. Set the equation equals to 0. When you bring the denominator on the top, the whole thing will be equals to 0 and you will have negative x to the power 3 by 2 plus 9x to the power half. Now, in order to solve them, take x to the power half common. Look here. It is so easy. Here power half, it means it has a 0.5 power. Here power is 3 by 2, it means it has 1.5 power. You can see 0.5 is a common. So I can take only x to the power half common. Now what is left? So 3 by 2 bigger power minus smaller power will give me the remaining power. So I will get negative x to the power 1. Now, if you have a doubt, what do? Half plus 1 gives us 3 by 2. So here comes to the original question. Plus 9, x power half is already outside, so no need to write, and then make it equals to 0. Now, one time, the first factor, that is x to the power half, equals to 0. And one time, the second power factor, that is negative x plus 9, equals to 0. Now here it means we have x to the power x equals to 0, and in our second, from the second factor, we will get x equals to 9. If you remember, our question was originally it was like x plus 3 over square root of x, which means in the domain x was greater than 0, which means 0 was not included. That means this is not our inflection point. The 0 is not our inflection point. Our inflection point is only 9. But let's solve and let's check whether we are right or wrong. So reason, for that reason, we have to perform our second derivative test. Let's perform the second derivative test. So make a number line. Don't forget to put the 0. Also put the 9, that is an inflection point, and from here we will find whether it is inflection point or not, because for inflection point the function should be continuous and the concave up should be changed into concave down or vice versa. Okay, now what you have to do, here is our second derivative. Choose one by one all the functions and keep writing it in the calculator, or do it manually in order to get the quicker answer. But remember, here the domain is all numbers which are greater than 0, which means on this side whatever you will put, you will get an error. Even at 0 you will get the error, so no need to waste your time. Just take a number from 0 to 9, and then from 9 till positive infinity. Put one by one in the second derivative of the function and choose the sign, write it on the number line. So you have 30 seconds to solve this question. So take your time, try not to make the mistake, because if you make the mistake, it will ruin your question. And I would suggest to use the table side of the graphic calculator, or you can use the scientific calculator also, but of course it is a lengthy process to write in the scientific calculator. So if we write here, for example, 5, we will get a positive number, and if we write a number greater than 9, you will get a negative sign. So you can see that positive means concave up and negative means concave down. So hence it is proved that x equals to 9 is an inflection point. So let's write down the concave up intervals, that is from 0 till negative sign. Remember that concave up means the second derivative should be greater than 0. Write down the concave down intervals where you will have a negative sign, means the second derivative is negative, which means less than 0. It will be from 9 till infinity. Now for the inflection point, you have to find out the x value and the y value. So if x value is written here, So in order to find find the y value, you have to replace this 9 in the original function. So original function was x plus 3 square root of 9. So replace x by this 9, here x, sorry. So 9 plus 3 over square root of 9. It will give us 9, 10, 11, 12. 12 by 3, so equals to 4. So f of 9 equals to 4. So the x value is 9 and the y value is 4 for this function. I know that this is a typical kind of the question, so I request you to write this function yourself and try to solve it from your own hand, because understand that the practice makes the man perfect, and until you won't write this thing with your own hand, using your own paper, own pencil, own style, you won't get this question correctly. You will make maybe in the start 1 or 2 mistakes, but don't give up. Keep trying, or maybe you are so intelligent then you might fulfill this question without making a mistake. So write in the comment that how many times you solved these questions to make it correct, how many mistakes you did it, and or did you manage to get it in one go or not. So I'm waiting for your comments. Thank you very much.